First of all, I'd like to introduce you to our fictional bank, Error Bank of India, and how Error Bank places a strong emphasis on security and uses cutting-edge technology. Next, in preparation for the attack, I will walk you through the structure of our demo fake app. Then, how to perform the actual attack. And today, I'll conclude the agenda by presenting how Digital.ai's Application Security product protects the Error Bank of India. So let's start with a little background into Error Bank. This is a pioneer digital banking institution at the forefront of financial technology, founded with a vision to allow access to banking service for India's diverse population. It's assumed the following architecture would safeguard its customers. So using a mobile device, logging into Error's Bank mobile banking app. The server generates a real-time token and sends it to the banking app to be stored on the device. The token maintains the session so that the user does not have to log in again, and this is used for all the financial transactions. Let me demonstrate this now. So, this is our Error Bank of India banking server and our banking mobile app. Let me just log in. Once I've logged in, we can check the balance, which is around $1,000. We can also see this file. This file contains the token from the server. The next topic we'll look around is the preparation for the attack. I'll walk you through exactly how this is achieved. So this is the structure of the attack. The victims download a fake app using a phishing site. This fake app communicates with the bank server and also communicates with a hacker's server. Our goal here is when the victim downloads a fake app through the phishing site, we will steal the token used to obtain the victim's financial information by sending a legitimate request to the banking server. In order to accomplish this, first we need to locate the bank server's address. So, using JetX, which is an Android APK reverse engineering tool, we can look at the Error Bank of India's mobile app. This is the code for the app. Looking at the source code structure on the left, we can see various classes. One here is the HTTP client, which at a guess we would say is responsible for communications. Let's look into this and confirm my suspicions. Yes, the token file. A hacker can expect this file to be created at runtime, and after going through some logic, we can find the functions for the server configurations. This method looks like it references JSON files for the server address. From my Android development days, I know that these JSON files are located in the resource folder. So let's check. I see, the server information is indeed here. If I switch to Postman, we should be able to send this GET command to the server without the need for the app. This is the IP and port number I got from the Error Bank of India's mobile app. I will send the GET command now, and below is the response. From this, I can verify that this is the correct URL. Let's analyze the code some more to see what else I can find out. This is the login method, and you can see this is an endpoint. This is also the endpoint for transfer, and it's also the endpoint for balance. Well, we use balance in our demonstration today. This method, getLocalHostEndpoint, explains how to complete the URL. So a HTTPS, put the host name and port number, and then add the endpoint such as the balance. Let's go back to Postman, and this time let's add the balance as an endpoint and resend the command. The server said this URL is correct, but you are not authorized. So how do we steal the token and perform the attack? In order to steal the token, I've created malware, injected it into the banking server, and repackaged this as a fake app. I will use this phishing site to deliver this app to my victims. So, the server on the right is the hacker server, and it is listening, and we will redirect it to fake app. This server hosts a phishing site. This is actually my company's website. It looks exactly like the original, as I copied everything, including all the HTML, CSS and JavaScript, but it's actually a fake phishing website, and if victims click the button, a fake app will be downloaded. Let me demonstrate. So let's go back to the mobile and connect this to the phishing website, and let's actually download the fake app. For clarity, I actually changed the icon to the hacker's icon so you can see it. So let's install this. Now, if you focus on the right hand side, the hacker's site, as soon as I open this fake app, you will see a session is opened. Let's log into the banking app. You can see the app logs into the server and we can see the balance. At the same time, we can find this text file. We have to see inside this file to find its key. To do this, we'll use the hacker's server. Let me expand the hacker's server so you can see clearly. Okay, let's connect to the victim's mobile device. If I type sysinfo, we can see the information of the victim's device and we can even get to the shell. Once in the shell, we can actually use Linux commands. For example, pwd, we can see the path and even see the file list. Let's go ahead and look inside of this file. Here is the token. Let me actually copy this and go back to Postman. This time I will give it the token and send the get command. Here is the response from the server and you can see the balance is exactly the same on here. So how does Digital.ai protect Error Bank of India? If you remember from the earlier steps, we create a phishing web app and mobile app, reverse engineered it using JetX, and I obtained the server IP and ultimately the key. So how do we block this attack? I will show you how using Digital.ai's Application Security we can protect your website and mobile apps, those being iOS, Android and hybrid, from ransomware, cyber threats and phishing scams such as the one being demonstrated today. Okay, let's check out the web folder of the phishing site to see the other version of the APK, the protected one, since I'll be using this different version of the app at this time. This app is protected by our solution. I will delete this file and just rename it to Bank APK. And I'll reconnect to the server and re-download this protected app. Let's download the app. So you can see at this time that I'll have a different icon. This is the police icon, not hacker icon. Let's go ahead and install it. So you can see here, as soon as I open this app, a session is also opened. But if we go to the monitoring app product, we can find some event information being triggered by the guard in the app, and we can drill into each event. This means the app is running on the emulator. And the app has been modified. The app has been repackaged. And the resource has been modified. You can see every information about the hacker. The IP address, the system information, and the time and region. In the case of actions, we can provide two types of actions. The first is a tamper action. The tamper action is to do any action that customer wants. For example, if I was to use the other version of the app, at this time within this app, I've set toast message as a tamper action and then make it crash. So let's do that and look out for the toast message and then the app crashing. As soon as the app detected any threat, the app did the action and crash. The other action is monitoring. So you can see as soon as an app detected any threat, the app reports to our monitoring system and providing visibility into apps in the wild. Using our protection, you can detect the fake app. The other thing the hacker used was the phishing site to deliver the fake app to the victims. So here in this folder, you'll see many CSS and JavaScript files. You can protect JavaScript files using our protection. The JavaScript file is the one used in this project and I protected this file. Here is the result. You can see on the left hand side that this is not protected, so you can read the plain text and logic. Whereas the one on the right I obfuscated, so everything is encrypted and obfuscated, and for added protection, I injected some of our guards inside this JavaScript file. This JavaScript file also knows which URL it should be called from. I will copy and paste this protected version inside of our project. So now, if we go back to the original phishing site and look at our monitoring system, we can see this event. Within the guard, I told it which URL it should be called from. So it should be called from Digital.ai. But this time, it's been called from this URL, which is why you can see this event. Here is your fake app. And lastly, the hacker could find out information about our back end. How can we protect that? The one on the left has not been protected, and the one on the right has been protected using our protection. The plain text has been encrypted and every function, logic, etc. has been obfuscated, so the hacker cannot find out any information about your back end. This is how you can protect your apps from attacks. Besides banking, we have customers in just about every industry. Anywhere you have data and information you need to protect for both you and your customers.